Good to look at you through a little tiny hole in my computer. Just kidding. So, this week we are focusing on a lesson that you probably don't love, and that is figuring out the difference between all the different kinds of numbers. So, I went through and looked at the Ed puzzles, and it looked like most people were good. Like you were answering them correctly, getting 100 or a 92 or whatever. And then I went through and looked at the Google form, and it's not as good. So I thought, okay, let me film a little thing of myself. I know you just see my little face in the screen. And hopefully, because this is my first time really using Screencastify, you are looking at what I'm looking at in terms of responses. So I thought I would just go through. But before I do that, look at me in the little screen. I have a little dry erase board. And I'm going to try to just give you that quick rundown because I think the reason why everyone hates this is it doesn't have any real relevance like to your life. So you're like, what is the point? And I get that. But the point is to try to have just a little bit of number sense. Does the name irrational and rational matter like a ton in the scope of the future of your life? No, but being able to decide whether a fraction can be written as, I'm sorry, whether a number can be written as a fraction or not is a decent skill to have. So it is something that we go through. So let me first just say the name real numbers. All that means real numbers is real numbers are just all the numbers that you've ever seen in your life. There's another section of numbers called imaginary. Guess what? We're never going to talk about them in this course. They won't come up until Algebra 2 and pre-calculus. So when you're doing a quiz, the answer is never imaginary. I liked it in the Ed puzzle because it kind of showed you, if you were interested in that kind of thing, what an imaginary number actually was. But you don't need to know that yet. Everything we do is a real number. Okay, so after the real numbers, we branch out into two categories. And every real number is one of these two things. It is either, can you tell me? Oh, right, we're not live. One is rational, and the other is irrational. Like, that's so crazy. It's irrational. So let's start with the irrational because there's less directions for irrational. So if a number is irrational, think like it's so irrational. She's being so irrational, making us learn this. She's crazy. So the irrational numbers are three things to think of. The definition is an irrational number is a number that cannot be written as a fraction. But to you, that probably seems like, ugh, so what? So the irrational numbers are numbers like pi. Pi is irrational. Do you know why pi is irrational? Well, pi is irrational because it's a decimal that goes on forever and never repeats. So therefore, it cannot be written as a fraction. When you were in grade school, they might have told you, hey, pi is approximately 22 over 7. They might have said that. See those little squiggles? I didn't write an equal sign. I wrote squiggles. I wrote squiggles because it means approximately. It doesn't mean equals. If I took my calculator, hold on, can't open it. If you took your calculator too and you put in 22 divided by 7, thinking like, oh yeah, I can write pi that way. How do I do this? Let's try it on my phone because you guys have your phones with you probably. Boom, boom, boom. 22 divided by 7. You'd get 3.140, but then that's not what pi is. Pi is supposed to be 3.1415926. So 22 over 7 is nonsense. It's not even pi. It's just kind of close up to the hundredths place. But after that, it falls apart. Nonsense. Pi cannot be written as a fraction. We should not think about it as 22 over 7. It's pi. It's irrational. That number goes on forever and it never, ever, ever repeats. So that's the thing about irrationals. They go on forever and they never repeat. So even if I wrote down a random fraction or a random number like 5.127964 and I wrote like a dot, 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 this number here, I'm giving you no pattern in the decimals. and I'm putting a dot, dot, dot to show it goes on forever. I cannot put the line over the numbers because that would mean I'd have like a repetition. But putting that dot, dot, dot means those numbers are going to go on forever and they ain't never going to repeat. So these are irrational numbers. The only other kind of irrational number is a square root that does not reduce. Oops. The square root of 5, the square root of 21. If I put them in my calculator, it won't be great because my calculator can only do so much. You guys know when you flip your calculator or your phone sideways, you can do square roots, right? So if I put in 5 and I square root it, oops, camera, there we go. 2.230 or 60679774997. It looks like you might get repeating, but you don't. Okay, nothing ever repeats. We don't get a pattern. So the irrational numbers, pi, decimals that don't repeat, and square roots that aren't perfect. When I say aren't perfect, what if I put the square root of 4? Well, the square root of 4, what is that? That's just 2. So that's not a square root that doesn't reduce. It does. The square root of 4 is 2, so I take that off my list. Okay? Those are the irrationals. The rationals are everything else. Oops, hold on 1 second. This is so crazy. It's pouring out, and I want my husband to take the dog outside. It's pouring. Can you take the dog inside? Question mark. Crazy life, right? My dog is long hair, and he's going to be very wet. So once you know what an irrational is, rational is everything else. So all the numbers that do repeat, even if they go on forever, square roots that do reduce and whatever. But the thing with rationals is there's other categories. So within rational numbers, we have rational numbers, we have integers, we have whole numbers, and we have natural numbers. Okay, so this is the way they go down, each getting more and more specific. So if something is a natural number, it's everything else in this column that comes above it. If something's a whole number, it's everything else that comes above it. If something's an integer, it's everything else that comes above it. And then if something's rational. So what I mean by that is start with the most specific. A natural number are the counting numbers. So those are things we count by. Like if I said, how many apples do you have? 1 or 2 or 3 or 4. It does not include the number 0. Oh, the dog is inside. Silly. So the natural numbers are 1, 2, 3, 4, and so on. The whole numbers are that same stupid list, but include 0 in it. 0, 1, 2, 3, 4. Okay, naturals and wholes. So if I said, is 2 a natural number? Yes. Is 2 a whole number? Yes. What about 0? Is 0 a natural number? No. Is it a whole number? Yes. All right, now integers. Integers take the whole numbers, but we go into the negatives now. So -3, -2, -1, 0, 1, 2, 3, and so on, all the way up and all the way down. So now if I asked you, is 0 a natural number? No. Is 0 a whole number? Yes. Is 0 an integer? Yep. So see how if once it's in a category, it's in every category that comes above it. Is 2 natural? Yes. So then it's also whole and it's also an integer. And then my last category. So what other numbers exist that are not these? Because these are only you can have 6 apples. I mean, I guess you can have 6.5 apples, but you could have 7 boats. You don't usually have like a half of a boat. So these 3 categories are just like whole things, real things that don't get split into parts. Rational numbers are all the things in between, including these numbers. So it's the fractions. Rational numbers are anything that can be written as a fraction, 2/5, -1/2, and so on. But it can also be 5 and 7 and 0. Okay, rationals, every number that you deal with except for these crazy things is a rational number. So all these fractions, negative numbers, positive numbers. So now if I said, is -5, what kind of number? -5 is not natural, it's not whole, but it's an integer. So therefore, it's also rational. So any number, if it's natural, it's everything above it. If it's whole and everything above it. If it's integer and everything above it. Or if it's a fraction, it's just rational. The only other thing you could maybe be tricked by is, what about repeating decimals? What about 1.333 repeating? 1.3 repeating, most of you know, is a fraction. It's 1 1/3. So it's rational because 1.3 repeating is the same thing as 1 1/3. So that's a rational number. Anything that can be written as a fraction like that is rational. Okay, between that and Edpuzzle, hopefully it makes a little bit more sense. I'm trying to talk to the camera instead of this little tiny picture of me in the bottom. But so now maybe you want to go through that homework again. So if I were with you in front of you, we would say, okay, let's go back to the homework. So I'm looking at that now. Number 30, or the number 36. Well, so go to my little thing. What is 36? Well, 36 is definitely natural. So it's everything that came above it. It's natural, whole, integer, rational, and it's also real. So it is not imaginary and it is not irrational. Go down to the next one. So 0.243728283723. Let's see, is there a pattern there? 24373723. Nope, no pattern. Just some crazy numbers. So I've got a decimal that goes on forever because the ... So once I know it goes on forever, if it repeats, it's rational. But if it does not repeat, it's irrational. So the only things that should have been marked there were irrational and real. Okay, go to 1/2. Right away, 1/2's a fraction, so it's in this category. Is it an integer or any of these? Nope, it's just rational and real. -8. Well, -8 is definitely not one of these crazy numbers. So -8, is it natural? Nope. Whole? Nope. Integer? Yes. So everything above? Yes, yes, yes. Uh-oh. I can't see this one. Let me see if I can see the question this way. It's weird for me. If I put the thing in as a symbol, I can't see it. Let me see if I can look at it this way. What came after? Yeah, square root of 5. Okay. So next was the square root of 5. That's what this one is. So look at my chart. Where does that go? Well, hello, it's already there. It's irrational and then also real, but that's it. So you can see a lot of people got that wrong. Next one, 0.141414141414. Okay, that's repeating clearly. So it's rational and it's also real. Next one is 0. Okay, so that's on this side. Is it natural? Nope. But it's everything else in this column. Whole, integer, rational, real. All right, this guy. So -32.50001. See how it stops? I don't have a ... It is not going on forever. Once that decimal stops and doesn't go on forever, it's rational. The only irrationals, they have to go on forever and they can never repeat. So because that stops, it's rational. Rational and real. All right, I can't see the next two. Let me go here and see. Okay, the next one's pi. The next one's square root of -3. Oh, that dog. Okay, did that one, did 0, did that. So is this pi? If it's pi, here we go, irrational and real. And if it's the square root of -3, that's imaginary. I won't put that on the test, but that square root of a negative is imaginary. Okay, I hope that makes some sense. You can always go back and you can redo the form and even resubmit it to me if you want me to just check it again and see if you have it right. So I want you to try this thing called Khan Academy. I don't know if you've tried Khan Academy yet, but I want you to go onto it. I'm going to put instructions on the classroom, so hopefully it'll make sense. I think I've already set up the classroom for you, so we'll see how it goes. I will be in school on Thursday, so I can help you work through some of your questions if you can't get on the Khan Academy. Um, on Thursday, we will review. We'll do maybe another form like this and make sure that you feel comfortable with these things. Then on Friday, we'll do I'm just checking my notes. Friday, we'll do a small quiz. I hope you enjoyed today's version of What Number Is It? Have a good day. I don't know how to stop this either, so might be a second. Ouch, figuring it out.